Hello everyone. In this video, we are going to solve a gate question. The gate question is on the forced commutator chopper. The question is, a forced commutator tierized step-down chopper is shown in the figure. Neglect the on-state drop across the power devices. Assume that the capacitor is initially charged to 250 volt with the polarity as shown in figure. The load current can be assumed to be constant at 10 ampere. Initially, THM is on and the THA is off. The turn-off time available to THM in microseconds when THA is triggered is dash, rounded off to the nearest integer. So we have this circuit in which the input DC voltage is 50 volt. This is the main thyristor. This is the auxiliary thyristor. And we have the capacitor, inductor, and the diode. These components are the commutating components. This is the main circuit where we have the input DC voltage, the main thyristor, the load, and a freewheeling diode. It is given that the load current is constant current, which is 10 ampere. And the capacitor is initially charged with 50 volt. Now we need to find out the turn-off time available for THM. That is nothing but the circuit turn-off time we need to find. So we all know that the circuit turn-off time is the time duration for which a reverse voltage is being applied across any device after the device is turned off. So we need to find out the time for which a reverse voltage is being applied across the device THM after it is being turned off. Okay, for that we need to solve the circuit. So for that, let us consider that this is the given circuit. For this circuit, we need to find out the reverse voltage that is being applied across the main thyristor after it is being turned off. Okay, for that we need to have the current, the capacitor current and the capacitor voltage waveforms. Okay, we can see here that the capacitor, it was initially charged with this side plus and this side minus. Okay, and we have the current, the thyristor. Let us take that the thyristor THM is now conducting. Okay, so once the THM is turned on, then since the capacitor is charged with this side plus and this side minus, this will, as soon as your THM is turned on, the diode will be forward biased as this path is closed now. So we will be having the current flowing within this loop, which will be flowing from the capacitor through the diode, through the inductor, through this conducting thyristor and back to this. So we will be having the ring circuit here. So this will be having a sinusoidal current which is flowing within this LC circuit. So that current will be of sinusoidal in nature, which will be as shown in the figure IC. Okay, then we know that the time duration for which this current, once this current is of a shape sinusoidal current, when this sinusoidal current reaches 0 at this point, at that time the diode will be turned off automatically. So at the same time, the capacitor, which was charged with this side plus and this side minus, is now will be charged towards minus Vs as shown in figure. Okay, so initially the polarity of the capacitor will be of this plus polarity, wherein this side plus and this side minus. And now it is charged towards, during this time when the current is flowing in as the sinusoidal fashion, the capacitor voltage will be charging with the cosine fashion, and it will be changing from Vs to plus Vs to minus Vs. The waveform will be of cosine fashion. Okay, so now after this, the diode is turned off at this point. Okay, so after which you will be having only the thyristor. Initially, the thyristor THM will carry the load current plus the capacitor current. Now THM will carry only the load current. Okay, so after the capacitor is charged towards minus Vs, then you will have the circuit as such without any change. Okay, now your capacitor polarity, the capacitor voltage is now ready to reverse bias this thyristor THM. Okay, for making the thyristor THM to turn off, what we should do is we have to turn on the thyristor THA. Okay, so this THA, if we turn on at this point, then what will happen is that the polarity of the capacitor, which is now this side plus and this side minus, it will appear as a reverse bias across the thyristor THM, so that your thyristor THM will be turned off at this point as soon as the thyristor THA is turned on. after that, the capacitor current will be now, since the THM is turned off, the load current, the capacitor will now carry the load current through the THA. Okay, so the capacitor current will be of will be equal to the 10 ampere, that is the load current 10 ampere, but it will be flowing in the opposite direction as that of the assumed direction. When the capacitor current is flowing from the top side to the bottom side, we assumed that the current is flowing in the positive direction. Now the current is flowing from the bottom side of the capacitor to the upper plate of the capacitor. So the current is now flowing in the reverse direction, and the current is of constant magnitude. So we have the capacitor current, which is of negative polarity, and it is of constant magnitude. During that time, since the capacitor current is of constant value, the capacitor voltage will rise in the linear fashion from minus Vs towards the plus Vs. And at this time, the THM is turned off. So we can see that after this time, the capacitor voltage, which is rising from minus Vs towards 0 at this point, during that time, the thyristor THM will experience a reverse voltage. So this period for which a reverse voltage is being applied across THM is called the circuit on-off time. So the question asked is that we need to find out only this circuit on-off time. Okay, so to find the formula for circuit on-off time, we need to have the capacitor voltage equation. We know that Vc is equal to 1 by C integral IC dt minus Vs. If we substitute the current, if we take this current, and we need to find out from this point to this point. So let us take that. From 0 to t, from 0 to time, and let us take that the current, since the current IC is of magnitude I naught, we can have I naught here and integrate the IC over dt. Okay, so if we do that, we'll have Vc is equal to 1 by C I naught t minus Vs. At this point, we can see that the capacitor voltage is reaching 0. So we are going to take this boundary condition here at Tc, Vc becomes 0, so that we can equate the 1 by C I naught into Tc equal to Vs. Okay, now, so if we do that, we will get the Tc as Vs C divided by I naught. The value of Tc is equal to Vsc by I naught, substituting the values of Vs, the value of I naught, which is given as 10 ampere, and the value of C, we get the value for Tc as equal to 50 microsecond. This is the required answer. So the time for the time Tc, the circuit on-off time, will be equal to 50 microsecond. Thank you.